So we have a third degree binomial here. 2x cubed minus 128 equals 0. And we're supposed to solve this polynomial. So first things first, we can simplify this. If we divide both of these by 2, then we'll end up with x cubed minus, I believe that is 64, equals 0. Next, we can cube root both the x and 64. Let's use a different color for this. And then we'll get x minus 4 equals 0. Then we can isolate x, and we get x equals 4. But there's only one solution out of two others, because we can tell by the degree here. So we can use synthetic division to find the other imaginary roots. Since we know 4 is a solution, we can use this in the little box here. We bring the equation, 2 is in the cubes, then there's 0 in the squared, 0 linear, and negative 128 as a constant. So we always bring down this number, so we get 2. Multiply this times that, and we get 8. Add these together, 8, 32. Adds 32 plus 0, you also get 32. 4 times 32 is 128. And you end up with no remainder. So now we basically reduce this to a quadratic. We get 2x squared plus 8x. Well, that was ugly. Plus 8x plus 32. With this, we can use the quadratic formula to solve for these imaginary roots. So we know that the quadratic formula is negative b plus minus square root of b squared minus 4ac all over 2a. So all we have to do is plug in this quadratic into this formula. You go and write that down. So we have negative 8 plus or minus square root of 8 squared, which is 64, minus 4ac over 2a, which is 4. Now we can simplify this to get negative 8 plus minus 64 minus 256 which is all over 4. Simplify that further, you get negative 8 plus minus 8i over 3 over 4. And we can even further simplify that by dividing all of this by 4 to get negative 2 plus minus 2i square root 3. So this and this can get a final answer of x equals 4 or negative 2 plus minus 2i radical 3. This counts as 2 solutions, and this is 1. To use Descartes' rule of sign, we have 2x cubed minus 128 equals 0. Notice that there is one sign change when it is positive. So we can go ahead and make a little table here. Plus real, negative real, and imaginary real. It's one sign change. If we do negative 2x3 minus 128, there is no 0. And using the leftovers, that means there are 2 imaginary roots, which we have over here, and 1 positive root, which we have over here. Alright, we have a quartic polynomial, x to the 4th power minus 2x cubed minus 3x squared minus 10x minus 40 equals 0. Initially, we can use Descartes' rule of signs to find out what we're looking for. We see that there is one sign change from positive to negative right over here, and there's nothing else, it's all negative. So we know that there's going to be one positive root. Then we change everything to a negative. We change the x's to a negative, sorry. And this will stay the same because negative x times negative x times negative x times negative x equals just x. Then we get negative 2x, you get a negative sign from this. Then when you go back to here, negative 3x is just 9, positive 9, and then you go back to negative. So that would be 1, this will become positive 2, and then back to a negative 3. So that's how we have all 4 from the degree. So now we can use alternatives. So we're either looking for 1 positive root or 3 negative roots, or we can find 1 positive root, 1 negative root, since we can get rid of an even number, and 2 imaginary roots. So instead of actually solving it, I will use a calculator because it's easy and it's fast. Boom! Desmos says that there are 2 roots, negative 2 and 4. Negative 2 is a negative real root, and 4 is a positive real root. But it shows 2 are missing, which means that there are 2 imaginary roots, which means this one is the correct one. Sorry, get out of here, Desmos. This one, you see his happy face? You see it? Yeah. Alright, now, since we know that 4 and 2, and negative 2 are roots, I can just write that down over here. We can use synthetic division to bring this down to a trinomial. So in the quadratic, or not quadratic, to the 4th quartic, we have 1, cubic is negative 2, quadratic negative 3, linear negative 10, and constant negative 40. So this one always gets down the first one. 1 multiplied by 4, you get 4. Negative 2 plus 4 equals 2. 8. 8 minus 3 equals 5. 4 times 5 equals 20. 20 minus 10 equals 10. 10 times 4 equals 40. And you get 0 remainder, which means it is a correct root. Now we end up with the cubic equation. X cubed plus 2x squared plus 5x plus 10. Now, if we want to find these imaginary roots, we want the quadratic equation. And since we haven't used negative 2, we can use negative 2 for another round of synthetic division. Let's do this in pink. We get negative 2 over here. 1, 2, 5, 10. So of course this one goes down. 1 times negative 2 equals negative 2. 2 minus negative 2, 2 plus negative 2 equals 0. Times negative 2 equals 0. 5, negative 10, and no remainder. So you get x squared there is nothing linear, so we just go to plus 5 equals 0. Now, we could use the quadratic equation if you really want to prove to yourself that you are correct. And for the sake of getting an A, I will. Negative b, there is no b value, nothing. So it's 0 plus or minus 0 minus 4ac minus 4 times, that's 20, all over 2a, that's 2. And you just get plus minus negative 20 over 2. Simplify this, 20 goes into I, then you get 4 and 5. You can continue down to 2. That's a pair. And now we put that in, so we get plus minus 2. This is left over, so we get I comes down, rad 5 over 2. Simplify that, divide by 2, divide by 2. You get plus minus I over rad 5. Then you go and put these together and you get x equals negative 2. X can equal 4. X can equal plus or minus I square root 5. And that is your answer to this math question. Please, I haven't been paid yet.